Section 2.11, Evaluate Probability Formulas Using Technology. This section is so awesome. First of all, it's our last one in this Unit 2, and it connects to the other sections that we finished doing. So for example, in 2.10, we evaluated formulas using tables, and then continuing in 2.10, we evaluated formulas using our geometric distribution formula. So this ties into those two things that we finished doing. Let's take a look. We're going to be using our TI-84 calculator. But first, before we explore our calculator, I want to point out our table. Remember, it's so important to read tables and not just scan over them and maybe be confused and then jump over it, right? So the goal is for you to read those headers, those titles, and everything that's in it so that you understand what's happening. Let's take a look at the left side. It says notation. So the notation that we're given is, in this first one, is P of X equals to 3. And I'm looking at the next value and kind of comparing the difference of what's happening. So obviously I'm giving an X equals 3, X is less than 3, and X is less than or equal to 3. We have also 1 minus P of X is less than or equal to 3. And that ties into something we did in section 2.10. So look back at that. So again, we're just learning to read this table. In the next column, what we see is using a formula. We have used this formula before, so when you're looking at this line here, this should look very familiar to you. We have had the notation when they give us P is our X value is equal to 3 and our P value is equal to 6/10, and we use the formula. But the cool part, what we're learning today, is to follow our TI-84 calculator. And before I jump into the calculator, before I take that out and show you, I want to show you the difference in some of the values. So I'm going to point out some of the things that I'm noticing. When I have an equals 3 here, I'm using X equals 3. I'm also using this function on our calculator that's called geometric PDF. Okay. Now, when I have less than 3 in the middle column, less than 3 would include 1 and 2. And so we cannot enter the value 3 because we are at less than 3. So what do we see that's different? First of all, this right here should be an F. Let's change that. That's a mistake. But the value is correct here. The function they're asking us to do is geometric CDF. And what you should notice is we're going to be using 2. Why 2? Because we're using 1 up to 2. How about the next row? It says X is less than or equal to 3. So if you're looking at our formula in the middle column, less than or equal to 3 would include 3, down to 2, down to 1. So we're using the CDF, which is going to add all of those up. And again, this should be F. We're going to use the geometric CDF function on our calculator. But this time we're going to be using 3. Why 3 and not 2? Well, the one right above was less than 3, which 2 and 1 are less than 3. This one has less than or equal to 3. So 3, 2, 1 are less than or equal to 3. And the last one, we have 1 minus. So what we see very different from the others is we're going to have 1 minus first. Then we're going to have the X is less than or equal to 3. So it's going to be 3, 2, 1. We want to add those up. Therefore, we have the geometric CDF, and our value is at 3. I spent so much time explaining this table for you because you're going to have your own deductions to make here. So when you look at 1 and 2, you have to make those choices of using your CDF or your PDF. You have to know the difference, and you have to know what X value you're using. That's why we practice reading these symbols here and in previous sections. Let's go ahead and try not question 1, but just what we see here in this first row. So I'm just going to follow the instructions. I'm going to show you my calculator. So here I have my TI-84 emulator. So you're going to click second. And how do you know you click second? You see a little arrow on your calculator. Bars, and then we're going to go down to E, geometric PDF. So that's 2, 3, 4. And we find the geometric PDF, hit enter. We're going to have a p-value of 6/10, enter, an x value of 3, enter, enter. Now you see it entered on your calculator, enter for answer, and we have 0.96. This is the answer you see right here. If you need practice with this 3, go ahead and go through all of this table and make sure that you're getting these answers. Let's try example number 1 together. Compute the geometric probabilities given that x is equal to 4 and p is equal to 5/10. Use a calculator and round to 4 decimal places. So I'm observing my first value here that I'm given is x is equal to 4. And so I know that I'm going to be using our geometric PDF because I don't have all the other values, right? So I'm just going to do PDF, and I'm going to have x is equal to 4 and our p-value is equal to 0.5. I love taking care of my thoughts first. I do not go directly to my calculator. I have to think about what I'm going to do. I'm setting myself up to write my answer here. This is going to be, let's take a look. Second, bars, go down to geometric PDF, enter, p-value of 5/10, an x value of 4, enter, and we have 0.0625 for x equals 4. Beautiful. Let's take a look at B. It says p of x is less than or equal to 4. Because it's less than, what we need is that those values of 4, 3, 2, 1. Therefore, we're going to be using a geometric CDF, and we're going to have x is equal to 4 because it actually has the equal sign, and we're using our same p of 5/10. Second, bars, we're looking for CDF, our p-value is 5/10. It hasn't changed. Our x value is also 4. It didn't change, but the difference is this time we're using the CDF, not the PDF. And we have p is equal to x less than 4, 9375. And our last one, find p of x greater than 4. And we do have a mistake here. I'm sorry. Let's go ahead and fix this. This should say x is less than or equal to 4. And so because we have that equal sign, we're going to use the geometric CDF. We're going to have x is equal to 4, and P is equal to our usual 5/10. Let's go ahead and set this up already. So we're going to have Px is greater than 4 is equal to, bring out your calculator. Here, this one's different because instead of going to second bars, we're going to go 1 minus and then second bars. Let's find our CDF. And our values are 5/10. Our x value is 4. And we end up with 0.0625. You go ahead and try example 2. In the next section, I want you to notice that we're going to be doing exactly the same thing. So in this table, I have the Poisson probabilities using technology. And so you have the notation that's given to you. If we were using a formula, this is what it would look like. And last, which is what we're learning in this sections, is the steps to follow for your TI-84 calculator. We're noticing that we have very similar to what we just went over with the geometric distribution formula, except this time we're going to use the Poisson PDF. You're going to be giving your values. Now we're going to have a similar situation in which if we have an equals to 3 value, we're going to be using our PDF. If we have less than 3, would have 2, 1, and 0, then we're going to be using a CDF. In the next row, we have less than or equal to 3, so that would be 0, 1, 2, 3, so we have CDF. Greater than 3 would actually become 1 minus. We already saw this flip in the earlier table, and so we would have our CDF because we want to include 0, 1, 2, 3. Great. You're going to try number 3, number 4, and then we also go all the way into the binomial probabilities. Very similar again, we have our notation, our formula, and your TI-84 calculator. We have PDF when we have an equal sign, and we have CDF when we have those inequality symbols, and they include something other than just the given value. You have 5 and 6 to try. Beautiful.